All right, so how did everybody do with the sigmas known in this case? So hopefully everybody did a good job, but if you did get stuck or have any trouble or anything like that, please let me know so I can make sure we get all this kind of stuff fixed before we move on. So with sigma unknown, so again, we've got the same four steps that we need to do for any claim, regardless of what's going on. So again, notice there's no difference between state the hypotheses because we're still dealing with mu's, even though we don't know sigma in this case. So our test statistic, again, looks exactly the same, except in this case, instead of knowing the population standard deviation, we're going to use the sample standard deviation in this case. And again, since we're trying to actually discover something about the mu, we're not actually going to know what the mu is. So we're really just looking at the sample mean, the difference of the sample means divided by that standard deviation. So that makes it look a little bit less scary. So now this is the big major difference between what we did with one variable and what we did with, we're going to do with two variables. So remember with one variable, a lot of the stuff came down to knowing the degrees of freedom. And so it was always one less than the total number. So if we sampled 10 people, our degrees of freedom would just be 10 minus 1, which was 9. Well, unfortunately, since this case, we've got two different samples going on and they don't even necessarily have to be the same. The way we calculate the degrees of freedom is a lot more complicated. So if you notice, here's the big massive formula for the degrees of freedom. So that's why this one is going to be, say, a little bit trickier to calculate the p-value on using like the methods that we've been using in the past. So in this case, it might be worth your time to like go through and set some of these things up, and then we may end up using the calculator a lot more to find the p-value for this one just because it is a lot more complicated. So I'm going to walk through and show you how to do it kind of the long way just so you can see. But again, you'll see it takes a lot of steps. So I'm not saying you can't do it and stuff like that, but just be mindful and be really careful when you type stuff into the calculator that you don't make a mistake, because that's going to be another way to mess this one up. All right, and then finally, draw our conclusion is exactly the same. So really the big difference is going to be that degrees of freedom and how we calculate that and how that actually plays in and stuff. So, all right, so let's look at, let's look at our, talk about the calculator real quick. So again, just like when we did a t-test for one variable, if we're using two variable, we're going to use the two sample t-test in this case. So, and again, you'll find it under the test menu just like before. And so now there will give you an option about pooling the data or not pooling the data. So in statistics, when they talk about pooling the data, that means whether you're going to kind of combine the data into one big group or whether you're going to leave the data as two separate groups. So in this section, when we're talking about the mean, we always want to leave the data as no. We don't want to pull it together and make it into a single type of data. So we want to leave our stuff that gives us our mu1 separate from the stuff that gives us our mu2. So always leave pooled as no. And then again, once you hit calculate, you'll see the t value, you'll see the p value, and all that stuff. So eventually you'll find it. It's just, we won't necessarily have to go all through the long formulas to find it. So, all right, so let's look at an example and see if how bad I butcher this up or see if I can actually pull it off. So we'll see. All right, so we're comparing diets. So are low fat diets or low carb diets more effective for weight loss is the question here. So a sample of 77 subjects went on a low carb diet for 6 months. At the end of that time, the sample mean weight loss was 4.7 kilograms with a sample standard deviation of 7.16 kilograms. A second sample, let me do it in a different color. So a second sample of 79 subjects went on a low-fat diet. Their sample mean weight loss was 2.6 kilograms with a standard deviation of 5.9 kilograms. Can you conclude that the mean weight loss differs between the two diets? So in this case, we're looking for the difference one. So this is going to be the equals, not equals. And then we've got our alpha level. So again, let me start off by just kind of writing things down first. So for me, I'm going to put it doesn't matter which one you choose. Like in this case, since low fat was first, I'm going to just make that mu1. And low carb was second. I'm going to make that mu2, even though they actually gave us the data backwards. But that's just how I'm going to write it down. So I'm going to do the stuff in orange first. So my sample mean was 2.6 kilograms. My sample standard deviation was 5.9 kilograms. And the number of people that were surveyed was 79. And so now for the low carb diet, our sample mean was 4.7 kilograms. Whoops, these should be all twos. Our sample standard deviation would be, where'd it go? 7.16. And our number of people surveyed were 77 in this case. And so again, I already kind of mentioned that since it's, is there a difference between the two? That means we're looking for the equals, not equals situation. So we've got H naught is mu1, equals mu2, sorry. And then H1 is mu naught 1 not equal mu2. All right. So now it's time to calculate the test statistics. So again, this is going to look fairly similar to what we did. So nothing really changes at this point, except in this case, it's going to be a t instead of a z. So we want to get our sample mean minus our other sample mean divided by the square root of s1 squared over n1 plus s2 squared over n2. And so again, since we don't know anything about the population mean, that's what we're trying to predict, I'm just leaving them out. It's just going to be considered 0 at this point. So our x1 was 2.6 minus our x2 was 4.7. And then our, that was ugly. And so our S1 squared is 5.9 squared all over 79 plus 7.16 squared all over 77. All right. So again, let me type this in, make sure I don't mess it up as I go along. So I'm just going to do the top first in this case. So 2.6 minus 4.7. 7. So it gives me negative 2.1 on the top. And now I need to do the bottom. So let's see. So now I need to do second square root, parentheses, 5.9 squared. And then get out of the exponent divided by 79 plus, what was it, 7 point something, 7.16 6 squared divided by, keep forgetting to get out of the exponent, divided by 77 in parentheses. So that gives me 62.83 something. Oh, I messed up. Hold on. I forgot a division sign. So hold on. Let me go back and fix that. So insert a division sign. All right, now try. There we go. 1.0. That looks more like it. And so now we want to put our negative 2.1 on the top. So if we just do negative 2.1 divided by second answer, that'll pull that 1.05 up. And if we hit enter, we get negative 1.99, or we might as well just round it to an even negative 2 in this case. So in this case, we got 1.05 something, something, something. So this gives us pretty much negative 2. All right. So in this case, what I'd like to do is I'd like to be able to compare this to the actual t-scores that we get. So now remember, since this is an equals, not equals, and we're testing at the 0.01 level, then that means that this alpha level is going to be divided in half. So what that means is we're going to have 0.005 down here and 0.005 down here. And then the rest is going to fall, the other 99% is going to fall in the middle. So in this case, this is our 99%. So this is our fail to reject range. And then these two ends down here are going to be our reject H naught range. So now the only problem is, so I've done the t-value for you. And this is where it gets a little tricky, because to find this t-value, we can't use inverse norm. To find, we have to use inverse t to be able to do this. And so now the good thing is, like, once we figure out the bottom, so like in this case, I can do inverse t005. I can get the other one for free because it's just symmetric around the origin. But if you remember the way inverse t works, let's go back to the calculator and figure it out. So if we go second vars inverse t, we put in the probability first, which is easy. But then the next thing it's actually asking us for is the degrees of freedom, which wasn't that big of a deal when we were doing the one variable, because we just took the number -1, and that was our degrees of freedom. Well, here I've actually got my work cut out for me to figure out the degrees of freedom. So let me go back and actually calculate the degrees of freedom, just so you can see how complicated it is. And I've kind of helped you guys out on some of these. So if you notice, like, I've actually calculated the t-score for you on all these practice ones, just to make your life a little bit easier. So except for practice 4, apparently. So I don't know why I didn't do it on 4. Oh, I don't know why I didn't do it on 4. Well, anyway, so I left one, I guess, for you guys to work on your own. But so in this case, and the other thing that's tricky is, like, on a z-score, we could always just, like, once we knew the alpha, like, we would always get the exact right z-score because it didn't change. Well, this one, even knowing that the alpha level is 0.01, if all of our practice problems were 0.01, it doesn't matter, because the degrees of freedom could be totally different, because the ends could be totally different and stuff like that. So finding the degrees of freedom is going to make this a lot more complicated. So ultimately, you may not want to do this all the time. So that's why I'm just kind of warning you ahead of time. So let's actually find the degrees of freedom. So let me write down the formula here so I don't forget it. So we've got S1. So basically the bottom of the square, or the square root stuff, squared. So let me write it all down here. So degrees of freedom equals, so S1 squared plus S2 squared all over N1. Oh, not over N1. It's not all over. No, whoops. Not one big fraction. Sorry. And then this whole thing squared. And then 1 over N1 minus 1 times, so then the first part squared again, so S1 squared over N1. Is it squared twice? Yep, squared twice. There's a lot of squaring going on in this. And now 1 over N2 minus 1, and then S2 squared over N2 all squared. Blah. Oh my God, this is a disaster. So, all right. So let me write in what we've got first. That way, hopefully I don't have to keep flipping back and forth 100 times. So in this case, so our degrees of freedom is going to be, let's see, 5.9 squared all over 79 plus 7.16 squared over 77. All that's squared. And then 1 over, so 79 minus 1 would be 78, just to make this a little bit easier. And then 5.9 squared over 79, all squared. Plus, and 1 over 77 minus 1 would be 76. And then again, 7.16 squared, all divided by 77, the whole thing squared. Whew! All right, so now I'll try to type this in the calculator without screwing it up. So that's another place we can mess this up. So in this case, so let me get rid of that for the moment. So we want to first start off with a big parenthesis. So 5.9 squared divided by 79 plus 7.16 squared divided by 77. And then we want to square the top. So get down from there. So then do divided by. So if we do this in one big step here. So now we want to do parenthesis. See, I think just one parenthesis at the moment. And then I'm going to do, and then I basically want to write it pretty much exactly how I wrote it on the document with all these different parentheses. So basically I'm going to have, that's going to be my outside parentheses. So then just write all these parentheses exactly like I've got it. So let's see if I can do that here. So 1 divided by 78. And then now we're basically copying the whole left-hand side of the end stuff. So 5.9 squared divided by 79 all squared plus 1 over 77 and then 7.16 squared divided by 77. Oh, whoops. Oh, that should be 76. This one should be 76, sorry. And then the bottom should be 77, which is right. And then square that whole thing. And then one final parenthesis. And, oop, something doesn't look right here. What did I mess up here? Oh, that's okay. That's fine. This is degrees of, I was thinking I had the z-score. It's like, oh my God, what did I mess up? No, this is good. So my degrees of freedom are 147. And I think I just rounded it to 147. You could add the decimals and stuff like that, which is fine. But I'm just going to do 147 in this case. So my degrees of freedom are 147. So now I can go back to the inverse t and do 0.005 comma 147 for my degrees of freedom. And if everything's it works out well, I'm going to get that negative 2.61 in this case. So inverse t 0.005 comma 147. And lo and behold, negative 2.61. So woohoo! So that tells me that, so basically, again, this is just showing me that alpha level and where, so this is kind of my second check. So in this case, you probably won't necessarily do this step just because it is time consuming and it's a lot harder and you're kind of getting bogged down in a lot of stuff that, and I don't want you to get confused about stuff that it does. I mean, it does make it a nice second check for solving this problem. But at the same time, like if it's so hard, I don't want you to actually go through it because it is pretty time consuming. So in this case, what this tells me is that, the end of my, the upper end of my fail to or reject H naught is going to be negative 2.61. And then if you're in this range, it's going to be fail to reject. And then once I get to 2.61 and greater, then I'm in the reject H naught range again. So based on my current t-score, which looks to be about negative 2 in this case, so that's not in the blue area. So it looks like right off the bat, this is going to be a fail to reject. But again, this is one of these ones where we want to use the calculator to kind of confirm that it's a fail to reject in this case. So now what we want to do is use the zeros and ones and stuff like that to do, let's see, the calculator command. So in this case, I would go with second vars, normal CDF. So in this case, I'm doing the lower end because my t-score is a negative, so I want to do the lower end. So that means I want to do negative 100,000, comma, negative 2, comma, 0, comma, 1. And in this case, I get a p-value of 0.022. Which is greater than 0.01, which is good. So that means it kind of confirms what we thought was happening in this case. So that means that we are going to be a fail to reject. So since our p-score, p-value, is greater than alpha, so we fail to reject. There isn't sufficient evidence to prove that there's that much difference between the two diets in this case. So there isn't sufficient evidence to prove there's significant difference. All right, so now yours should be a lot. Oh, now let me show you before I talk about the next one. Let me show you the calculator command so we can see how we would do this on the calculator and stuff. So let me look at the numbers real quick, see what I need. So 2.6, 5.9, and 79. So let's switch to the calculator here. So not second, just stats, test, 2SAMP t-test. And so in this case, we want to enter our sample mean, standard deviation, and N1, and then again, choose the right one. And so again, notice on mine, it's got pooled on. So I want to check it that way. So that way pooled is off. So I want to turn pooled off for this one. And then now I've totally forgotten what my numbers are again. So 2.6, 5.9, 79. So 2.6, 5.9, 79, and 4.7, 7.16, 77. 6 and 77. And then again, this one we want to do the less than or equal to job E. And so notice our t-value is exactly what we had before, so negative 1.99. So our p in our degrees of freedom is exactly right. So our p-value looks slightly different, but it's still greater than 0.01 in this case. So it looks like we're still safe and saying that we fail to reject in this case. So this looks good. So again, can be a little tricky, but again, just kind of be careful. So again, I've tried to make it a little bit easier on you by finding the degrees of freedom for all these guys. So the fact that you've got the t-score here means that you know the degrees of freedom, or that you don't have to actually find the degrees of freedom to actually calculate these guys. So for some reason, and I'm not sure why, I don't know how I left out practice 3. I thought I had done, oh no, that one's got it. So which one? Practice 4. So for some reason I didn't do practice 4. So before tomorrow's class, I'll get the t-scores up on that one also. So that way you don't have to actually calculate the degrees of freedom if you want to, or if you don't want to, or and stuff like that. So let me know if you have any questions or anything. So practice these 4. And then when you're done, come on back and we'll talk about a little bit of probability.